In this section, we are looking at inverse proportions, which are the opposite of direct proportions, which we previously looked at. For direct proportions, when one variable increased, the other variable also increased, or when one variable decreased, the other variable also decreased. For inverse proportions, the variables are going in opposite directions. Our table here shows an inverse proportion. By looking at the table, you can see that as the number of workers increases, the time decreases. This table shows us the time it takes construction workers to pave a road. We are trying to determine whether T is inversely proportional to N. If so, we need to identify the constant of proportionality. Our equation that we're going to use for an inverse proportion is the opposite that we would use for a direct proportion. In a direct proportion, we used y divided by x equals a constant. In an inverse proportion, we're going to use the opposite of division, which is multiplication. We use x times y equals a constant. We're going to start by identifying what our x and y values are. In this problem, we're going to use the line that says tell whether t is inversely proportional to n. So we are comparing t to n, so t would be our y value, and n will be our x value. Now we're going to multiply each t by its corresponding n, or each y by its corresponding x value. We'll start with 36 times 1, which gives us 36, 18 times 2, which gives us 36, and 12 by 3, which also gives us 36. When we multiply each y by its corresponding x, we end up with a constant of 36. Therefore, this table does show us an inverse proportion with a constant of proportionality of 36.